Hello, our presentation today is on addition and multiplication as objectives in mathematics, and this will be presented in two parts. This is part one. My name is Jan Burcham, and I will be completing this presentation for you. First of all, we want to examine what we know about how children construct number sense. We know that number sense develops gradually. It's not something we can just tell children. It develops slowly over time. We also know that if children are able to think more flexibly related to mathematics, then they are able to use and solve problems in many different ways. Therefore, we want them to develop what we call numerical networks, so that a number is not just a number. It also has all kinds of relationships to other things. We know that children gradually construct the systems of tens, 100s, 1000s, etc. We also know if children can reason and understand about mathematics, then representing number with signs and symbols becomes much easier. So the focus is on the reasoning and understanding, not just the representation. In their construction of number, we also know that they tend to rely on counting all versus counting on. Children count all because they need to. It's still too difficult to hold a number in their head at the same time and then count on to that. They will begin to count on when they are developmentally ready. Here's an example of numerical network from the textbook. As you can see, it looks at the meaning of 7, and within that top circle, there are many, many different representations of 7. So we can think about 7 in lots of different ways. Even doubling 7, then we can think about 14. This network could be expanded, and this is not something that we're trying to get children to memorize, but it is something that represents how we want them to be able to think about number. Here's an activity that I would love for you to try. Take a number, select a number, any number other than 7, and then think about the kinds of relationships students might make with that particular number and draw your network. You want to reflect on why developing this kind of network is desirable. If you think through it, then you're more likely to fully understand it. So after you finish this presentation, take a few moments and develop a numerical network. So what is it that we know about how children construct computation strategies? First of all, children develop strategies to solve problems. We know that they count on, they invent tens, hundreds, etc., and then they partition numbers going the other way using tens, hundreds, etc. We also know that if they're left alone to develop their own understandings of computation, they typically begin on the left with addition and multiplication. And when we're teaching them traditionally, we teach them to start on the right. So that's counterintuitive. They start with the largest quantity. So for example, if they're adding 50 plus 25, they're going to start with 50 plus 20 is 70 and then put the 5 on. They also use nice numbers. These are numbers that make it a little bit easier. Doubles, 5s, 10s, those kinds of things are easier, so they will change problems to make them be nice numbers or easier numbers and then add on what's left. They also translate more difficult problems to different, more easily solved problems, as I was just explaining. So what does that mean for our teaching? First of all, we know that addition and multiplication are much easier than subtraction and division. Therefore, they technically should be taught first. And why is this so? Well, addition and multiplication are positive processes. Children can think in one direction without having to reverse their thinking. And subtraction and division require children to reverse their thinking, go back and forth. They have to think about the whole and the parts at the same time. In addition and multiplication, you don't have to do that. We should begin with the content Putting problems in the context of a story makes it more understandable. I know as high schoolers typically, or college students, we typically don't like word problems. We find them to be more difficult. Children actually have an easier time when problems are placed in the context of a story or a word problem. So we want to put things in that kind of context so they can understand it. Another important thing is that the difficulty of a problem is determined by the size of the second addend or the multiplicand, so the second number, not the answer. You see lots of textbooks that will say children are going to solve problems to 10, to 20, etc. What makes a problem difficult is not the answer, but the size of that second number in the problem. For example, 12 plus 2 is much easier than 2 plus 7. So it's not the size of the answer, but the size of that second number. If you think about it, that makes total sense. Children, even very young children, can add 150 plus 2, but they find it very difficult to add 2 plus 7. The easiest problems for children are those that include doubles, adding 1 and adding 2, and then making multiples of 5s or 10s. So you want to keep those things in mind and start with those. Now I'd like for you to watch the videos that follow in this module. You will see a class solving problems, and look for and take notes about 2 things. And you'll see various clips of the different steps with this class. First, look for strategies children use to solve the problem, and second, look for the role of the teacher.